Before we move on creating the cop network that's going to actually composite our textures, I want to talk a little bit about the gamma correction and how we have to make sure that any information that we get from the source textures and the texture that we render out are correctly set up. So in this setup, I just went ahead and downloaded same texture with the different extensions. So you see they have a JPEG, I have PNG, and I have EXR file. And you will notice that these do not look the same. So PNG and JPEGs are actually gamma corrected images, while the EXR are not. And we want to make sure that whatever the file format that we import our textures from, we want to make sure that this information is consistent between all the file formats. And this is where the gamma correction comes into play. And to explain a little bit more about the gamma correction, I found this great article in the Cambridge in Color website that I'm going to link probably in the notes, which basically talks about gamma correction and why is it important for us to gamma correct images. And if I could basically summarize this entire article in one sentence, it will be that gamma encoded images store tones more efficiently. And if you take a look at this graph, it talks about how our eyes do not perceive light the way the cameras do. With digital camera, when twice the number of photons hit the sensor, it receives twice the signal. And you can see that in this chart, if we could imagine that this horizontal line is something that we can measure the brightness or luminance of some object, that we could scientifically measure it. It will be the horizontal graph, and the vertical graph would be how bright that object would appear to us for our eyes with this green line, not with green but the blue line. You can see that for us at the 25% luminance, for us this object would appear already more than 50% bright of the brightness that we can actually perceive. And when it gets even brighter, you can see that we are really getting diminishing returns at the very bright object parts, but something like at the low brightness, 0 to 25, we can see almost basically 60% of the brightness scale for that for our eyes would be the more than 50% bright. You can see this perceived as 50% as bright for our eyes is already at less than 25% of the luminance value. And basically this means that we want to encode our images. For our images to look correctly, we want to make sure that we encode our images with this curve. Also, this is compared to camera, we are much more sensitive to changes in dark tones than we are to changes in bright ones. There is biological reason for this. It enables our vision to operate over the broader range of luminance. Otherwise, the typical range in brightness we encounter outdoors would be too overwhelming. And this is also important since gamma encoding redistributes tonal levels closer to how our eyes perceive them. Fewer bits are needed to describe the given tonal range. Otherwise, an excess bits would be devoted to describe the brighter tones, where camera is relatively more sensitive. A shortage of bits would be left to describe the darker tones, where the camera is relatively less sensitive. You see that with the linearly encoded coded gradient, we would lose the dark tones a lot more. But if we gamma encode it, you can see for us each step of the color looks like it is gradient is smooth. So that all is in theory, and how we're going to handle it inside Houdini is pretty simple. We're going to basically undo any gamma encoding once we import the images inside Houdini, and it's done very simply. We're basically just going to, for every file node inside cop network, we're going to enable this raw toggle inside parameter. And the gamma encoding is usually stored as a metadata inside the file, and that means that we can go ahead and basically Houdini can read it and undo any gamma encoding. And you can see that for the files that are not gamma encoded, doesn't have any data about gamma encoding. It doesn't apply any any gamma, does not try to undo gamma encoding. You see, I can toggle it here, it doesn't do anything, but for something like that has a gamma encoding done, it's going to undo it. And right now we have basically all the same images inside here. All the images are the same. And you can think about it as we're basically moving every tones that are written on this chart, we're basically moving them outwards, and it's basically going to make them a lot brighter for us. So we have made sure that our data is consistent when we are importing it. And how can we make sure that it is consistent when we want to export it? And this is going to be done basically automatically based on the extension that we want to render our texture out. Inside this ROP node, I have basically left everything the same except for the color space. I put my color space to raw, and doing some experimentation, this is going to basically say that we leave the gamma encoding to the extension that we want to export it as. So something like a JPEG and PNG is going to be automatically gamma encoded. Houdini is going to automatically gamma encode it. And something as a EXR, it is not expected to be gamma encoded, so it's going to leave it as it is when we are actually rendering it out. And I have rendered them all out, and if we take a look at them, you can see I have a JPEG and PNG is basically the same image, but for the EXR file, if I open this up, it is not going to be gamma encoded. You can see we have basically the same image. So this is how we are going to handle the gamma encoding for the textures. So this is going to be its own separate video before the actual top network creation, because it is an important aspect of the creating our new textures.